Welcome to a lesson on the addition and subtraction of polynomials. Notice in example 1 we're adding polynomials, and example 2 we're subtracting polynomials. Adding and subtracting polynomials is almost exactly the same as simplifying algebraic expressions, which we've already done. Remember, to simplify algebraic expressions, step 1 was to simplify within the parentheses, which normally doesn't apply when adding or subtracting polynomials. Step 2, we use a distributive property to eliminate the parentheses, and step 3, we combine the like terms. So going back to our examples, notice how we cannot simplify inside the parentheses because we don't have like terms inside the parentheses. So to clear the parentheses, if it's helpful, we can think of distributing a positive 1 here, and because we have addition, we can also think of distributing a positive 1 here. Well, we know when we multiply by 1, nothing changes. So when adding polynomials, we can simply drop the parentheses. We would have 3n squared minus 2n plus 8 plus 3n cubed minus 7n squared minus n minus 9. And now we combine like terms. And to put the terms in descending order, we'll start with the highest degree term first. Notice how here we have n cubed, so the highest degree is 3. There's only one degree 3 term, so we'll just rewrite this in our sum. We'd have 3n cubed, and now we'll look for the n squared terms. Notice here we have 3n squared, and here we have negative 7n squared. Well, 3n squared minus 7n squared would be negative 4n squared, or minus 4n squared. Now we'll look for the n terms. Here we have negative 2n, here we have negative n, where here the coefficient would be negative 1. Negative 2n minus 1n would be negative 3n, so we write down minus 3n. And now we look for our constants. Here we have 8 and then negative 9. So 8 minus 9 is equal to negative 1, so we have minus 1. So this would be the sum of the two polynomials. Distributing to clear the parentheses is extremely important when subtracting polynomials. Again, notice how we don't have any like terms inside the parentheses, so we want to clear the parentheses. So to clear the first set of parentheses, we can think of distributing a positive 1, but because of the subtraction, to clear the second set of parentheses, we would distribute a negative 1. By distributing a negative 1, we make sure we end up subtracting each term in the second polynomial. So when we distribute positive 1, we just have a cubed plus 5a plus 11. And now when we distribute negative 1, we'd have negative 4a cubed and then minus 6a squared. Now here we have negative 1 times negative a, that becomes positive a or plus a. And then we have negative 1 times 1, that's negative 1 or minus 1. And last step, again, we combine like terms. So starting with the highest degree terms first again, that would be the degree 3 terms. So here we have a cubed and negative 4a cubed. Of course, the coefficient here is 1. So 1a cubed minus 4a cubed would be negative 3a cubed. And now we'll look at the a squared terms. There's only one a squared term here. It's a negative 6a squared. So our difference will have minus 6a squared. And now for the a terms, we have 5a, and here we have a, which of course is the same as 1a. So 5a plus 1a is 6a, so we have plus 6a. And finally, looking at our constant terms, we have 11 and negative 1 here. 11 minus 1 is equal to 10, so we have plus 10. This would be the difference of the two polynomials. Let's take a look at one more example. Again, notice how there are no like terms inside the parentheses. So for the next step, we'll clear the parentheses. So we'll distribute 1 here. Because of the subtraction, we'll distribute negative 1 here. And because of the addition, we'll distribute positive 1 here. So we have 3x minus 1, and then we'll have negative x squared. And negative 1 times negative x is positive x, so plus x. And negative 1 times negative 9 is positive 9, so we have plus 9. And then, of course, distributing positive 1 doesn't change anything, so we have plus x cubed plus x squared. minus 7x plus 2. And now we'll combine like terms. Again, we'll start with the highest degree term first. Notice here we have an x cubed, so the highest degree term is degree 3. There are no other degree 3 terms, so we have 4x cubed. And now we'll look for the x squared terms. Here we have negative 1x squared. And here we have x squared, or 1x squared. Well, negative 1x squared plus 1x squared would be 0. So these terms drop out. And now we'll look for the x terms. We have 3x here, we have x or 1x here. And we also have negative 7x here. So 3x plus 1x is 4x. 4x minus 7x is negative 3x. So we have minus 3x. And then finally for our constant terms, we have negative 1, 9, and 2. So negative 1 plus 9 is 8. 8 plus 2 equals 10. This would be our simplified expression. I hope you found this helpful.